The objective for this lesson is to show you how to solve radical equations of this form. X to the m over n equal to k. Now note that this expression here, x to the m over n, can also be written as the nth root of x to the m. So in other words, the equation here, x to the m over n equal to k, can be written as the nth root of x to the m equal to k. Now to solve this kind of equation here, we have to make sure first that the expression that contains rational exponent or radical expression is isolated to one side of the equation. And then the next part, to solve for x, we will just have to raise both sides of the equation here by the reciprocal of the exponent of x. Now, in other words, if you have x to the m over n equal to k, you raise both sides of this equation here by n over m. So you have x to the m over n raised to n over m, and also the right hand side will be k raised to n over m. Now recall, if you have something like this, if you have x raised to n and then raised to another exponent, all you need to do is copy x and multiply the exponents here. So you have nm. So by multiplying n over n times n over m, this cancels and that cancels. So this gives you 1. So that makes it just equal to x. So you have x equal to the expression here, k to the n over m. Now, this is the case if actually the numerator here for the power is an odd number. If it is even, you would need to add the sign here, plus or minus. So you will have two roots if the m here is even. And then it's always nice to check all the proposed solutions in the original equation to find out if they are actual solutions or just an extraneous solutions. To illustrate, let's consider the following examples. So we are to solve x to the 3/2 equal to 27. So since this is already isolated, the expression that contains rational exponent is already on one side of the equation, then we'll go ahead and raise both sides of the equation here by the reciprocal of the power of x. So in other words, we have x to the 3/2 raised to 2/3. And we do that same thing on the other side of the equation. So we raise 27 as well to 2/3. Now this would just result to x because 3/2 times 2/3 is just equal to 1. So that is just x. And then we go ahead and solve for 27 raised to 2/3. So you could plug this into your calculator, or without using a calculator, you can express 27 as a power of 3. So this is, we know 27 is 3 cubed. That's 3 times 3 times 3. That's 3 cubed. Raised to 2/3. Then by using laws of exponents, we're multiplying the exponents here. The 3 here cancels out. So that's equal to 3 squared, which is equal to 9. Or you can just go ahead, if you don't want to do this, you can just go ahead and plug this into your calculator. You could plug this in as the cube root of 27 squared. And you will get the same value, which is equal to 9. Now, for the next example, we have x to the 4/3 equal to 81. Here, since the numerator here is even, we will have to add a plus or minus sign to the right-hand side of the equation. So we still have to follow the steps, so following the steps, we would have to raise both sides of the equation by the reciprocal of the power of x. So we have the reciprocal of 4/3 is 3/4. So you raise both sides of the equation by 3/4. So you have 81 raised to 3/4. Now, again, since this is even, we will have to add plus or minus here. So it will have 2 roots. Now, you apply laws of exponents here, multiplying 3/4 by 4/3. That's just equal to 1, so that gives us x. X to the 1 is x. Then we have plus or minus 81 raised to 3/4. So if you're going to use your calculator, you could write this as 4th root of 81 cubed. Now, since I'm not using a calculator, I will just write this in exponential form. So this is equal to plus or minus, I would still copy plus or minus. Now 81 is actually equal to 3 to the 4th. That's 3 times 3 times 3 times 3. 3 multiplied to itself 4 times. And raise this to 3/4. Cancel the 4. You have plus or minus 3 cubed, which is 27. So plus or minus 27. You got that same value when you plug this in to your calculator. So you got that same value, plus or minus 27. Now, example number 3. Suppose we are to solve for x plus 2 raised to 3/4 equal to 64. Now, just take note that sometimes this is not written this way, but rather sometimes it could be written as the 4th root of x plus 2 cubed equal to 64. So if for instance, if you are given something like that looks like this, your first step is to write it in this form. So you have to write it in this form first. Then after that, you follow the steps, which is you raise both sides of the equation here by the reciprocal of the power here. So you have x plus 2 to the 3/4 raised to the reciprocal of 3/4, which is 4/3. And you do that same thing to the other side of the equation, raised to 4/3. Now, we will not worry about adding the plus or minus sign because this is 3. The numerator here is 3, which is an odd number. So we will only have 1 root in that case. So let's go ahead and solve this. This cancels. That's just equal to 1. So the left-hand side is just x plus 2. And then the right-hand side, 64 to the 4/3. Plug this into your calculator as cube root of 64 to the 4th power. Or you can solve this using laws of exponents. You can also write 64 as 64 is 2 to the 6 or 4 cube. Okay, 64 can be written as 2 to the 6 or 4 cube. So I'll write it as 4 cube. 4 cube raised to 4/3. The 3 cancels out. So you have 4 to the 4th. Now 4 to the 4th, since we know that 4 cubed is 64, then multiply it again by 4. That gives you 256. So 256 is the value here. So in other words, you have x plus 2 equal to 256. Then you solve for x. You subtract -2 on both sides of the equation. You have 254. Now, example number 4. To solve this, we will just have to raise both sides of the equation by the reciprocal of the power here. We will have to raise both sides of the equation by 3/5. 3/5. Then the left-hand side be equal to x minus 3. So just equal to x minus 3. Now, this 32 here is also equal to 2/5. So that is 2/5 raised to 3/5. So the 5 cancels. This is equal to 2 cubed, which is equal to 8. So that is just 8. And transpose this to the other side, or adding 3 on both sides of the equation, you have x equal to 11.